Hey everyone, in today's lecture, I'm going to show you how our applications can stay decoupled and highly scalable using asynchronous workflows. Now this is going to work by using an event-driven model where we actually emit events using the EventEmitter library on NestJS backend. And when we receive those events, we can process a certain job. And we also create a server-sent event connection from the backend to a NestJS UI here. So in this case, you can see my NestJS UI has been loaded. Now on my Postman here, I can go ahead and trigger a new request to create an account. Now when this account gets created, it's going to generate some new snapshots in the background using an event-driven approach, and that's going to happen asynchronously. So if I go ahead and launch a request to get my snapshots now, it's an empty array. However, if I now create this account and fetch the snapshots, you can see that they are populated. And again, this is happening through an event-driven model asynchronously. The accounts service actually doesn't call the snapshot service directly. Instead, it's merely emitting an event, and the snapshot service will pick that event up and process it. Additionally, we can see on the NestJS UI, we received this snapshots generated event, and this is thanks to a server sent event connection we have established to our NestJS backend. Additionally, this is user specific, so only events that we trigger with a given user ID will actually be consumed by that given user here on the client side. So I'm so excited to go through this architecture with you today and see how we can get up and running with an asynchronous event-driven model. Let's go ahead and get started next. So this example is actually coming from a new net worth tracking application that I am building and making available to the public. So if you want to learn more about this application and start using a really great net worth tracking tool, I'll leave a link below where you can check it out. So we have access to Plaid to be able to actually link all bank accounts seamlessly and have account balances updated multiple times a day to generate these net worth snapshots over time. We can click into individual accounts and get details about that account and transactions on it. So again, if you'd like to learn more about it, I'll leave a link below. Finally, if you want to get access to the full version of this lecture where we actually implement the UI as well to see how we can implement this event-driven flow end-to-end from a backend to a NestJS UI using our server-sent events, be sure to head over to my website. I'll leave a link below where you can get access to it, where you'll get immediate access to tons of exclusive member-only content and all of my best-selling Udemy courses, all available. So thank you so much for watching this video. Let's go ahead and jump right in. All right, so to go ahead and get started, let's go ahead and use Turbo Repo, which is going to be a mono repo manager that we can use to host both a Next.js and NestJS application in one mono repo in one workspace. It'll make it easy to run both of them. So I'll go ahead and run npx create turbo at latest inside of the directory I want to create the project in. I'll go ahead and select yes. And then you can specify the path to the directory where you want to install it. I'll go ahead and set this to NestJS, Next.js, event-driven. And then choose your package manager. I'll go ahead and use npm. So go ahead and wait for the project to initialize and all your dependencies to become installed. All right, so now the project has been initialized. I'm going to go ahead and cd into that project directory and open it up in my code editor. So I've gone ahead and opened it up in VS Code now. Now we can see the starting project here for a new Turbo repo. Now, if you want to learn more about Turbo repo and how it's structured and how to take most advantage of it, I'll leave a link below to another lecture where we do a deep dive into Turbo repo. So let's go ahead and modify our Turbo repo to get it into a clean starting slate with both a Next.js UI and NestJS backend. Well, we can see by default in the apps directory, it creates a docs and web directories. We'll go ahead and keep the web directory since this generates a Next.js application using the modern app directory approach. However, it also generates this other docs application that we don't need. So we can go ahead and move this one to trash. So now we have our single Next.js application. In packages, we can also remove the shared UI library since we won't actually use it. Let's go inside of this Next.js application. Inside of the app directory, we can remove the starting page module CSS and remove everything from global CSS as we won't be using any of this. And finally, in page.tsx, let's go ahead and just reset this to export default function home and just return an empty JSX expression here. So by doing this, we should have a clean starting project that we can go ahead and now run. Now we can go ahead and use the turbo repo dev command to start our application in development mode, and we know turbo repo will execute this for all applications. Now I'm also going to go ahead and make sure we set our application port for our NestJS server at port 3001 to not conflict with our NestJS server that we'll create later on. So let's go ahead now and run the turbo dev command to start up our development server. And we can see here that we started the server up and can access the application at localhost 3001. Alright, so I'm at localhost 3001 and we can see this empty blank screen here, which is great. It means our Next.js UI is ready to go. Let's go ahead and now add our Nest.js backend to this turbo repo. To do this, we'll go ahead and back in the terminal, let's cd into the apps folder, and we need to make sure we have the Nest.js CLI installed. Of course, if you don't have it, you can install it globally with npm install at Nest.js CLI at latest. Once you have the Nest CLI, you want to use it to generate a new Nest application using the Nest new, and then I'll call this backend, since in the context of our monorepo will be the Nest backend, and we'll use the npm package manager to stay in line with our monorepo. So go ahead and let it initialize inside of our monorepo. So now at this point, we should see inside of apps, we now have the backend folder with our starting Nest.js application inside, which is great. The only change we're going to have to make is in the root package JSON. We have the start dev command, which we normally run to start our Nest development server. We want to make sure this is just dev so that it aligns with our turbo dev command and will become executed when we run it. We can also go ahead and remove these starting app controller files since we're not going to use this in our project. So let's go ahead and clean this up and start from a blank slate. We'll also remove them from our starting app module here. So now at this point, we have both our UI and backend configured. Let's go back to the terminal, to the root here, and now rerun our turbo dev command to start up both our Next.js UI and Nest.js backend in the same terminal session. So now you can see we have both of these running. We can flip between them with our arrow keys, which is great. Now we have the application up and running. Let's go ahead and start simulating this scenario where we have this coupling between our Nest.js modules and services, leading to a circular dependency and the need to use forward ref. So in this example, we're going to have two modules with controllers and services that have a direct dependency between one another, and then we're going to see how we can break this dependency and this tight coupling with an event-driven model instead of a synchronous one that requires this coupling and circular dependency. So to get started in a terminal window, make sure we cd into apps first and then into backend, and we'll reuse the Nest CLI to generate these modules, controllers, and services. So we'll go ahead and use this Nest CLI to firstly generate a module called accounts. So this will go ahead and create accounts module. Now create one called snapshots. Next up, we'll go ahead and do the same thing now for a controller. So we'll generate a controller for snapshots. And finally, a service. And lastly, let's go ahead and now create a service for accounts and a controller for accounts as well, all using the Nest CLI, which is going to go ahead and update our modules as necessary. So our root app module is now importing these two new modules. And now snapshots and accounts, we each have a empty controller with the appropriate prefix, a module that declares the controller and service, and finally the service itself, which is just an empty injectable right now. So now let's go ahead and introduce some business logic into these services and introduce this dependency between them. So now let's go ahead and go into our accounts service, where we want to add some functionality to create a new account and actually be able to return. Now in this example, we can just simply use an in-memory array to store these accounts. Now additionally, when we do create the account, that's when we're also going to want to trigger the generation of our account snapshots at a given point so that we can record the balance of it at a point in time and present this to the user in a graph format potentially. And so this is where we're going to actually introduce this circular dependency and coupling between our accounts and snapshots. So in this account service, we'll have this private read-only accounts array initialized to an empty array. And then we're going to go ahead and create the create method that will allow us to pass in a given account. And then we simply push the new account onto our accounts array. And so now we've added this new account to our in-memory array. We also want to create this getAccounts method to be able to expose the accounts. So we simply return this accounts from getAccounts. Now let's head over to our snapshots service, where we want to implement business functionality in here to generate given snapshots for all the accounts in our system. So the snapshot service is going to have a private read-only snapshot array initialized. And then we're going to have a generate snapshots method here. Now, generate snapshots, well, this is where we actually want to now get access to our account service so that we can get all the accounts and create a snapshot for it here inside of this array. Well, we know to do this, we can inject dependencies in our constructor. So we'll add the private read-only account service in the snapshot service constructor here. This will allow us to inject it as a dependency. So now we have access to the account service inside of generate snapshots. We want to use it to pull back all the existing accounts at this point in time. So we can call our getAccounts method. And now what we want to do is loop through the accounts array. So we have a for constant count of accounts. And so for each account we have, we want to push on our snapshot array using snapshots. Make sure this array is called snapshots plural. And we call push on it. And we'll add a new snapshot. So in our case, that'll simply record the given account details and then the time that the snapshot was generated. So we'll add a date property here, initialize it to a new date for now. So now we have an idea of this account state at any given time thanks to adding it to our snapshots array, and we can query this back to the user who might want to get access to this historical data over time. So we'll have a get snapshots method here and return this .snapshots. Well, now I want to go back to the account service because actually when we do create a new account, that's when we want to actually trigger this snapshot process to actually begin and generate at a point in time so that we have up-to-date snapshots as soon as a user adds a new account. Well, to do this, we now need to inject the snapshot service into the account service. So this is how we would typically do it. And notice this is going to introduce a circular dependency because we're now forced to actually import the snapshot service inside of the account service here. So we've added it to the constructor. However, we know the snapshot service is also importing the account service to actually get the accounts we need to generate the snapshots. So with the snapshot service and account service, we'll now call snapshot service.generate snapshots to begin the process as soon as we add this new account and it's available in our system. So we know this is introducing a circular dependency between our application. Now in this example, we could also potentially refactor away from this dependency by updating the snapshot service to simply take in accounts here as a function parameter. However, I want to keep this example in place because this is a common issue you may see in many different types of applications where we have circular dependencies between services or modules in a NestJS application. And yes, in this simple example, we could potentially refactor this away to no longer have this dependency. But in more complex applications, this might not always be possible. And instead, what we want to do is refactor to an asynchronous workflow where we can actually emit an event to generate these snapshots from anywhere in our system and have them triggered without having this explicit dependency. There's a lot more benefits to using this asynchronous workflow, including decoupling our system and making it more resilient in general. So let's go see how we can do this. Before we do that, well, let's make sure our application can actually start up. If we go ahead and try to run turbo dev right now, we can see that our backend is going to have some errors because we haven't wired up our dependency injection properly. So let's start off by going to the snapshots module and make sure we add the exports array and export the snapshot service Next up, we'll go ahead and add the imports array, and now import the accounts module so we can get access to the account service, which we know is going to rely on that circular dependency and tight coupling between these two. So we'll do the same thing now inside of the accounts module. So we added the accounts service here to the exports array, and now let's add an imports array where we import the snapshot module. So now you can see that our Nest application is actually still failing because of the dependency injection. Now this is actually the error you will see, this undefined dependency exception, when you have a circular dependency inside of your application. We can even see NestJS here is warning that this may be due to a circular import. Now, next up, I want to show you how you can actually temporarily get around this issue with the forward ref decorator, which NestJS introduces to allow us to bypass these circular dependencies directly in our code. Later on, we'll actually refactor away completely by using an asynchronous event-driven workflow, which is the preferred approach. But let's see how we can start up with the circular dependency using forward ref. To do this, we're going to go first to our snapshots module, and when we import the accounts module here, we need to make sure that we actually wrap this in a call to forward ref from NestJS common. So inside of here, this takes back a function that returns the module we're trying to import, in this case the accounts module, and this will support circular dependencies. Now in the accounts module, let's do the same thing with the snapshot module import. We add the forward ref, pass in a constructor function here, and return that snapshot module inside of forward ref. Now finally, we have to do the same thing for the actual services themselves when we inject. So inside of the account service, we're injecting the snapshot service. To tell Nest this is a circular dependency injection, we use the @inject manual decorator here, and then supply the forward ref function again and return the snapshot service type. So now the circular dependency will be supported here. We finally do the same exact thing now inside of the snapshot service when we import the account service. So as you can see, this is a lot of extra code and complexity to support this circular dependency, and it's why we want to prefer to refactor our code away from it in the first place, because we have this really tight coupling and additional complexity with forward refs. And finally, make sure we update the type here to be the account service that we're returning from forward ref. And now at this point, we can see our Nest application is actually successfully starting and compiling even with these circular dependencies in place thanks to forward ref. So lastly, let's go ahead and add controllers to both of these so that we can test out the functionality through our HTTP routes. So in account controller, let's go ahead and expose a post route here to create a new account. So this will use the app body decorator and extract the account request. Let's define a type for this here so we can create a new create account request file. And so this will be exporting the class create account request with the properties inside. In this case, we'll take in the name of the account as type string and the balance of the given account of type number. So now we have the properties defined. We can reference the type here in create account request. And now in create account, we're simply going to call our account service. So let's go ahead and make sure we inject that in our constructor. So now we have the account service injected. We can finally return this .account service.create and pass in that account request to add it to our accounts array. We know this will also go ahead and generate our snapshots. So let's go ahead and in the snapshots controller, expose a get route to actually be able to return our snapshots. We'll firstly add a constructor to make sure we can inject the snapshot service. And we'll go ahead and add this get route, get snapshots. That'll just go ahead and return this .snapshot service.get snapshots. So now we have the ability to create an account, generate those snapshots, and retrieve them. Let's go ahead and test it out inside of Postman. So back in Postman, let's launch a new post request at our server at HTTP localhost 3000/accounts to create a new account. Remember, we need to pass in this JSON body. So send a raw JSON object here. We'll provide a name for account. I'll call checking and pass the balance property. I'll set this to 250 for this account. So if we send this off, we can see we have a 201 created, so it was successful. This should have added it to the accounts array and generated the latest account snapshots. Let's test this out by launching another request. We can see we get back this array of snapshots. Inside of here, we have the one for the account we just created. So this checking account with the date timestamp it was generated for. So this is excellent. This is working as expected. However, we now have this really tight coupling between our accounts and snapshots, as well as this ugly circular dependency. Let's go ahead in the next part of the lecture, refactor this to an event-driven asynchronous model and see if we can actually utilize it on a NestJS UI. All right, so now we're ready to refactor our code to remove this highly coupled approach and move to an event-driven asynchronous flow for our application. And to do this, we're going to utilize NestJS EventEmitter package, which provides a simple observer implementation for us with very little code. So it uses the EventEmitter 2 package internally and allows us to produce events and attach any consumers on them so we can process code asynchronously in the background. And in our case, I'll also show you how to set up a NestJS UI to this architecture to receive the completion of an event through server-sent events so that we can actually react to it, fetch data, or do whatever we need to do whenever the event is completed, which is a very typical use case. All right, so our first step is to install with npm save at nestjs/eventEmitter library. So go ahead and install this dependency. When we have EventEmitter, we now need to configure it in our application. So we'll go into the root app module, and in here we can add the new EventEmitter module from NestJS EventEmitter and call for root on it to initialize it. Now this is going to ensure we have the same singleton instance of the EventEmitter throughout the whole application. So whenever we produce or consume events, it's all happening in the same context. And this is all we have to do to wire this up. So now we can take advantage of this EventEmitter inside of our account service, where we want to refactor to remove this circular dependency on the snapshot service. And instead, when we create this account, we'll simply generate an event to generate the snapshots, which will happen asynchronously, and remove the need to have this direct dependency on the snapshot service. So to do this, we're going to go ahead and remove the snapshot service from the constructor. We don't need to inject it anymore. So that will remove the circular dependency, and instead we inject the event emitter of the type EventEmitter2 from NestJS EventEmitter. So now that we have the event emitter, let's use it to generate a new generate snapshots event. Let's go ahead and define this as a new class inside of snapshots folder. We'll create this generate snapshots.event. Now this does need to be a class in order for NestJS to serialize it properly. So we'll call it generate snapshots event. And here we can define any data the event will take in as a public property that we can access on the event consumer. To do this, I'll add a constructor and add the parameters here that we pass in when creating the event. So in our case, we can pass in some dummy data like a user ID of type string that the snapshot will be associated with. So now we have the event in hand. Let's go ahead and back to the create method. We'll use the event emitter to produce this new event. To do this, we call the emit function, and then we need to specify the name of the event. So this event name is going to have to be the same on both the consumer and this emit call for the event to actually synchronize between the two. So we'll call this snapshots.generate, and then we pass in the data. Well, this will be the new generate snapshots event, and pass in a dummy user ID here of 123. So lastly, let's remove our snapshot service import and the imports to forward ref as we no longer need them. We can then go back to the accounts module and remove our import to the snapshots module and get rid of that ugly forward ref. Back in the snapshots module, let's do the same thing. We can remove now the forward ref since we have only a one-way dependency between snapshots and account now. Finally, go back to the snapshots service and also remove the forward ref here since again this circular dependency is gone thanks to the event emitter. So now we're producing this event, we need to actually associate it with a method. Well, in our case, we know that is going to be in the snapshots service, the generate snapshots method. To do this, we simply decorate any method inside of a NestJS injectable class with the name of the event inside of the onEvent decorator. So here we'll use the same event name we used when we emitted earlier, which was snapshots.generate, and that will ensure whenever we emit that event, this method here will get called. And so we have this asynchronous communication between emitters and receivers, and we can also specify the event that we're getting passed in here, which is going to be the generate snapshots event. So we'll go ahead and use the event to add a new user ID to the snapshot. So we'll pull up the user ID, and now this should be everything we need to actually have this asynchronous event flow set up. Back in our terminal, we can restart our development server with turbo dev, and you can see our application starts up with no circular dependencies. Let's go ahead and test out the new functionality. So back in Postman here, if I get snapshots now, it's an empty array. Let's go ahead and post this account once again. So the account was created. Now if I get the snapshots, we see the snapshot generated with the dummy user ID, showing that the event was emitted, and we actually generated the snapshot here, which is excellent. This is happening asynchronously. Now, of course, this workflow can cause some challenges initially when working on a UI, because we have this asynchronous workflow now occurring. We need a UI to actually be alerted when the generate snapshot process actually completes, right? Because now it's asynchronous, it's happening in the background. And let's say a UI actually wants to know when this event is complete and ready for the client to actually ask for this data, which is a common use case in an event-driven model. Well, one approach to this is polling the server, which can be resource intensive. Another great approach, especially when working in modern UIs like a NestJS application, is to use server-sent events, where we establish a long-lived connection between the server and client that the server can push data back onto the client whenever it wants. And in our case, we can let the clients know through this long-lived server-sent event connection that this snapshot event or any event has completed. So let's go ahead and see how we can set this all up inside of a NestJS UI in the next part of the lecture. Now we've refactored our code to be decoupled and asynchronous, which is great. However, the new problem we have with this architecture is, well, if we have a UI that's actually waiting for, in this case, snapshots to be generated, they need a way to be alerted when the snapshot generation is complete and they can ask for more data. Since this is happening asynchronously in the background, the UI could pull the backend for its status on the job, or more preferably, what we're going to do is use server-sent events to actually notify the client when the event has completed. Now, server-sent event works by establishing a long-lived connection between the server and client, and then the server can push data back to the client at any point. So it's similar to WebSockets, except it is a one-way persistent HTTP connection where the server pushes to the client. It also makes asynchronous event-driven workflows like this very useful and pragmatic. So let's go ahead and see how we can set this up. Firstly, we need a way to actually dispatch these events through our NestJS application. So to do this, I want to centralize this into a new events service. So let's go ahead and open up a terminal window and go into our backend. We'll use the Nest CLI to generate a new events module, and then a new service called events as well. So now we should have this new events service and module. Let's go ahead and add this event service. So I also want to show you how we can make these events scoped to a particular user, because often when we have an event in our system, we want it to pertain to a given user, and we don't want to notify everyone connected to our backend in this event. The event is usually scoped to a single user who we want to target. So what we can do is actually hold on to all the persistent HTTP connections inside of this service. NestJS automatically abstracts server-sent events using observables. So when we create a server-sent event route later, we're going to return an observable. And whenever we emit on that observable, that's going to push data from our server here to the client. So we want to keep track of these streams or observables inside of our event service that are user-specific. So let's create a new map to do this. We'll call this user streams. This will be a new map with a string key we'll use as the user ID, and then the subject for that given user. So make sure we import subject from RxJS. So as we can see here, a subject is a special type of observable that allows us to manually emit values on any given observable stream. So in our case, that's going to be us pushing data from this server to the client over that persistent connection. So we'll add a type to subject here and set it to any, because we'll make this event service abstract that can be used for any event. And so now we have these user streams. Let's go ahead and create a new get events method that will be passed in a user ID of type string and return an observable of type message event. Now, message event is a special type reserved specifically for server-sent event connections and represents the payload over a server-sent event connection. So what we're going to do here is generate the observable that we're actually going to return from the server-sent event controller that we'll create later on. So let's go ahead and firstly create a new user stream, or get the one that already exists, because if one already exists, we can reuse it. We'll go ahead and abstract this to a new method called get or create stream and pass in the given user ID. And now let's create a new private method that will go ahead and do this. So we'll have get or create stream. Given a user ID, we return a new subject of type any. So we'll go ahead and firstly check to see if user streams does not already have the user ID as a key. Then we need to create a new stream and set it. So let's do this. We'll set on user streams the user ID as the key, and a new subject, which will represent the observable, as the value here. Otherwise, if the user stream does exist, let's go ahead and simply return it. So this will be the same user stream that we don't have to duplicate. And we can push any event on this persistent connection, which will be scoped to a particular user. So now we have a way to get the user-specific stream. We also want to create another stream on the observable that's going to be representing a keep alive for our persistent server-sent event connection, because by default, if a server-sent event connection doesn't have data sent along it, a lot of clients, in this case web browsers, will actually close out the connection prematurely due to keep alive timeouts. So just like how keep alive works over HTTP, we want to implement our own keep alive mechanism that will emit a message on the server-sent event connections every so often, so that the connection is kept open and we have the ability to send data on it at any point, even if there's been a long delay since the last event was received. To do this, we'll create a new keep alive observable here using the interval operator from RxJS that allows us to create an observable that emits every period that we provide to it. In our case, I want to emit a value automatically every 25 seconds on this persistent stream. And we'll simply pipe here a map operator where we return, in this case, this is going to represent the data sent along the server-sent event connection. I'm going to set property comment to keep alive. So this is a common approach to implement keep alive in server-sent events. And so now what we can do is finally return the final observable, which will be a call to merge from RxJS, where we can combine multiple observables into one. We'll pass in our user stream dot as observable, and then the keep alive observable as well. Last but not least, we're returning the final observable, which is our user stream and this keep alive. Let's also pipe another operator onto it called finalize, which is going to execute whenever the observable is about to complete. In our case, we want to actually make sure that we remove our user stream from our map, so that when users disconnect from the client, we actually remove their entry from the map and we don't keep them in here and use unnecessary memory, because if we have lots of users connecting and disconnecting, this map will keep growing if we don't update it. So when the user disconnects here, which will be when finalize is run as the observable or long-lived connection is closing, we can call this .userstreams.delete and pass in the user ID. We can also log out and say the user by user ID disconnected. So now we have this getEvents method to return our server-sent event persistent connection. Let's finally create a sendEvent method that we can call from our application and send an event to this user using the persistent connection at any point. So this will take in the user ID to who we want to send the event to, the event type string, which will be a property we define on every event to define the type of it, and lastly, some optional data if you want to push data on the event as well. So the first thing to do will be to obtain the user stream. So we can call this .userstreams.get, pass in the user ID. So if the user is already connected to our server sent event here, that means they'll be inside of our user streams map, and we'll have the subject here that we can emit events on. So let's check to see if the user stream was found, then we can emit on it using userstream.next, which will emit the next value on this observable. In our case, we want to set the data property, which exists on any message event, the data that we push on the server sent event. And here we can pass whatever we'd like. So in our case, I want to include the event type, which will be a system-defined event type string, and we can spread any data that was included on the event. So now our event service is correctly configured to be able to establish the connection to the client and send events in our application code. Let's go ahead and finally create an events controller where we can return the server sent event to the client and establish it. To do this, let's go ahead and again generate some code with the Nest CLI. We'll run nest generate controller events. And now in the events controller, let's go ahead and define this new server sent event route. First thing we'll do is add a constructor where we can inject the event service. And now let's mark a new server sent event route in our application. To do this in NestJS, we can simply use the @SSE decorator, which is going to mark the route here as a server sent event route. So make sure we import SSE from NestJS common. And then we can pass in the name here. I'll just call this route SSE. So the method here, I'll call it SSE, turning this .eventService.getEvents. And in this case, well, we're going to pass in the user ID. Now, usually this user ID would come from your authentication process. However, in our case, we know we're simply hard coding our user ID currently to 123 for our snapshot generation event. So let's pass this same user ID down to the getEvents function. So thanks so much for watching this video. If you want access to the rest where we go over how to integrate this on the NestJS UI, I'll leave you a link below where you can head over to my membership website, get access to hours of exclusive member-only content, and all courses available. Thanks so much for watching, and I'll see you in the next one.